Hello guys, welcome to the first part of the series on graphs. In this series we will study about graphs and its working. So let's get started. This is an introductory video and has the basic terminologies and the types of the graphs. We will see what is graph and how each type differs. The definition of a graph is that it is a pair v, e, where v is the set of the nodes called the vertices and e is the collection of pair of vertices called edges. What it means is, if we have two nodes called vertices and then we join them with a line which is called edge, then this structure is called a graph. When we see this graph and focus our attention on the edge, we see there is no arrow to show the direction of the edge. This type of edge is called undirected edge. An undirected edge has an unordered pair of vertices. We can write the pair as u, v and v, u. Railway lines are a good example as they run in both directions. Now if we give direction to the edge and it points from u to v, the edge is now a directed edge. The pair is now ordered and it's u, v. Here u is the origin and v is the destination. A one-way road traffic is a perfect example for a directed edge. As we have two types of edges, we can also differentiate graphs into two types: a directed graph and an undirected graph. As the name suggests, a graph with all the directed edges is called a directed graph. In World Wide Web, web pages are considered to be vertices. There is an edge from page U to another page V if there is a link of page V on the page U. This is an example of directed graph. A graph with all undirected edges is called undirected graph. In the flight network, a flight goes to and from between two destinations and thus have no specific direction. It is an example of undirected graph. Now consider we have only one node and the edge from this node is connected to itself. This type of edge is called self-loop. Now if we have two vertices and two edges are connecting them, then the two edges are parallel to each other as they connect the same pair of vertices. Now another terminology used in graph is called degree. A degree of a vertex is the number of edges incident on it. So the degree of vertex A is 3 because here are 3 edges incident on it. Similarly, degree of D is 2. Now this is the case of an undirected graph. What about directed graph? In case of directed graph, there are two types of degree: in degree and out degree. In degree represents the number of edges pointed towards the vertex, while the out degree represents the number of edges pointed out from the vertex. So now the in degree of the vertex A is 1 and the out degree is 2. I hope I am clear till now. If you face any issue, feel free to comment below. Moving to subgraph. If we have this graph initially and then we delete some of the vertices and edges from the graph, then the remaining graph is called the subgraph of the initial graph. When we talk about graph, we often hear about path. A path in a graph is nothing but a sequence of adjacent vertices. So if we need to find a path from E to D, then in one of the ways it would go from E to A to B to D. Now how about finding a path from A to A? Well, do you think it is possible that the path exists? Here we come across cycle. As we see, A is connected to B, which is connected to D, which is connected to C, and it is again connected to A. So the path from A to A is possible, and the same is the definition of a cycle. A cycle is a path where the first and the last vertices are the same. We have this graph where there are 4 vertices and 4 edges. Is this a connected graph? It is not, because in a connected graph there is a path from every vertex to every other vertex, and in this graph we cannot reach vertex C. So if we change one of the edge, we get a connected graph. Then there is a complete graph in which all the edges possible are present. Variant of graph is sparse graph, where there are relatively fewer edges. And then there is dense graph, where are most of the edges. The difference between the two is quite vague and depends on the context. We have seen a directed graph and an acyclic graph. The combination of two is called a directed acyclic graph. It has directed edges and has no cycle. This type of graph is nothing but trees. We are teaching trees too from beginner level, so do watch it. Suppose there are one-way routes from one point in city to other, and then we give weight to every edge. This weight is nothing but the distance between the 2 points. These type of graphs are called weighted graphs. They can be directed or undirected. In a graph with v vertices, number of edges can be anywhere between 0 to v into v minus 1 by 2, because each node can be connected to every other node. Lastly, let's see the application of the graphs. Some of the applications are: it is useful in transportation related problems like flight or road, in computer networks to visualize the data flow, and in databases to show entity relationships. We will wrap up this video here. Up next, we will see how to represent graphs in computer science. Thanks for watching.